Assalamualaikum and good morning. This is Dr. Aida, and today we are going to have a look with two examples from the concept of abstraction in Java. Okay, now abstraction is a kind of process of hiding implementation details and showing only the functionalities of certain classes that you're implementing. That means when we do the programming, we are hiding the internal details from the user. Now, there are two ways to achieve abstraction in Java. One is by using abstract class, and the other one is by using interface class. We are going to cover both through tracing examples in this video. And I will start with the one on the screen, which is an abstract class. Okay. So basically, an abstract class is a class without implementation. Okay. And we represent the class, the abstract class in UML diagram in the form of using italic fonts. So if you see the UML diagram on the screen, I have the superclass is person. Then there are three more classes, which is full-time student class, inherits from person, employee also inherits from person, and part-time student PTS inherits from employee. Okay, but if you notice, I try to make it as italic as possible, but person class should be an abstract class. Okay, so let's have a look at the coding that you see on screen. There is one class. This is the main class. Okay, class tracing abstract. There is one main method there, and then we have four more classes. Full-time student that extends person, part-time student that extends employee, employee that extends person, and finally a class person. But if you notice, there is a keyword abstract before the word class in person class. So in abstract class, basically it is a class without implementation. It contains an abstract method. So if you see public abstract void display, we have one definition of display. Display is a method, but it is an abstract method. What is an abstract method? It is a method without implementation. If you notice, straight away after the closing bracket, we we terminate the statement public abstract void display with a terminator. Okay, so with a semicolon. So that means there is no implementation there. So what is the purpose of this? So that, remember, abstraction is part of information hiding. This means the implementation of method display can be tailored to any kind of implementation that you want. You can reuse, you can override the method, but with different implementation, and the implementation itself is hidden from the user. Okay, so if we have a look here, if you see in full-time student, the method display will print out the string, the student ID is, and concatenate with the variable student ID. If you see the method display in part-time student, it will print out the string, the student ID is, and it will concatenate with the value of student ID. And in employee, we have a different implementation of display, whereby it will print out the string the ID is concatenate with the value of employee ID. Okay, so again, this is a very useful class provided by Java. So we will have a look at this entire program again, and we should be able to do the tracing. So again, in tracing we have two parts, what happens in the memory and what happens on the display, but I'm not going to go into detail of tracing. The constructor chaining works the same. Remember, okay, let us just do the first line in the main method, which is person obj1 equals to new part-time student, what the compiler will do is compiler will create an object named obj1 from the person class, but by calling the with argument constructor in part-time student. Okay, so when we go to and the compiler will send the value 111 and 222. So if we go to the with argument constructor in part-time student, 111 will go into the variable employee ID, but the employee ID will be set to the constructor, superclass constructor of part-time student, which is employee. Okay, so what happened here? Compiler will go to the with argument constructor of employee, send in the employee ID, and then print the first line. Oh, before the compiler assign an ID to the employee ID, the compiler has to create person first, which is the abstract class. Okay, and in the abstract class person, the constructor will return one string, which is person class. That is what will be displayed on the console. So after the person class has been created, compiler will return to create employee and set the employee ID, then print out the string employee class, and then go back to, where were we? And go back to part-time student and assign the value this student ID equals to student ID. Student ID was 2222. Okay, and go back to the main method. So that is part of the constructor chaining. We have not gone into the display method yet, but it is very straightforward, because if you see, we are calling the same method, the same name, display, but from different object. And what is important here, because display is an abstract method. What is an abstract method? It is a method without implementation. Okay, and we hide the implementation so that each of the implementation is very specific to each class. Remember, abstract class, it is a class, but we design it to be abstract by having an abstract method inside it. An abstract class can contain both abstract method and concrete method. Okay, so the opposite of abstract class is concrete class. Those are the class that we have been dealing before this. Okay, so try this out. You will see the full output as displayed on the screen. I will continue with the interface class. Okay, this is the second example. The name of the class is tracing interface. Now, remember, there are two ways to achieve abstraction in Java. One is by using abstract class. The second one is to use interface class. Okay, what you see here, let's say in the program, we see the total of 4 classes. The class tracing interface, then interface X, interface is also a class, Y is a class, and Z also a class. And if you notice, class, the keyword implements and not extends, because the keyword extends is used to indicate that one object is inheriting or extending from another object. A subclass extends a superclass. But in this case, class Z implements X, and X is not the superclass. X is simply an interface class. Okay, so interface is basically an elegant way to define public services of a class. Things that be shared. For example, if you have a construction class, maybe you keep the roof color or certain values that will not be changed at all, that will be used the same across everything, or base salary of your employee in your company. Okay, now remember, in interface there is no attribute, and a class, for example class Z, can implements multiple interface. Okay, but this is different from inheritance, because we can only inherit from one class at a time, but we can implement more than one interface at a time. And one interface, for example, interface X, can also extend from multiple interfaces. So that is basically the concept of interface. We keep things that do not change in interfaces, in interface classes. So we can see from here there is one class Y, and the UML diagram you will see one separate class Y, and there is another class Z which implements class interface X. And how do we know that that a class is interface in UML? There will be a notation interface on top of it, on top of the class. Remember, if we have abstract class just now, the name of the class will be italicized. But here in interface class, we have the keyword or the indication interface over there to indicate that that is an interface class. Okay, so basically it's the same. Tracing is easy. You go through the constructor chaining and go through line by line. Compiler will always start with the first line from the main method, and you will see the final output as indicated there. There are only two lines: constant from interface X 65, constant from class Y is 45. Okay, so basically that's about it. Abstraction, abstract class, and interface in Java. Very easy, and we must take this opportunity to use the facility that Java has provided. Okay, bye.